let's understand relationship between zeros of a polynomial and its coefficients. Relationship between zeros and coefficients of polynomials. Let's begin with linear polynomials so that you understand easily. Linear polynomial. Now the standard form of linear polynomial is ax plus b. Now if k, a real number, is a zero of this polynomial, let k, real number, be zero of this polynomial. Then what happens to this p of x is equal to ax plus b? If k is 0, then we get, if k is 0, then we get p of k is equal to 0. Right? So p of k means now a k plus b will become 0. A k is equal to minus b. K is equal to minus b by a. Yes? So k is our 0 minus b by a. We got this list. So for this value of k, it becomes minus b by a. Which means minus b. B is a constant in this linear polynomial. Which means minus constant divided by coefficient of x. A is what? Coefficient of x. Right? Which has got, that means coefficient of x. Here x raised to 1. X itself is the highest, x raised to 1 is the highest degree, highest exponent. And this is coefficient of the variable with the highest or highest exponent. Coefficient of highest exponent variable. 0 is equal to minus constant by coefficient of x. Now keeping this relationship on one side, which is k is equal to minus b by a. This is for linear polynomial. Let's keep this on one side, and now we'll see how we can find relationship between coefficient and the zeros of quadratic polynomial. Let's try to understand for quadratic polynomial. So you know the standard form of quadratic polynomial is ax square plus bx plus c. Let's keep this on one side. Let's try to understand this by taking an example of a quadratic equation. Now I will take example of this equation 2x square minus x plus 6. I am taking this example to explain relationship between zeros and coefficients of polynomial. Now we know how to factorize this. So just a quick review of how to factorize. You have 2 times 6, 12. Find factors of 12. Such factors by either addition or subtraction we should get minus 8. Right? What are such factors now? Let's see. 3 times 4 factors we have, and then we also have 6 times 2. Now 3 times 4, either by addition or subtraction, we don't get this middle term, right? So let's not take this. Now let's see 6 and 2. Do we get this middle term 8 either by addition or subtraction? Yes, we get. We get by addition. But here we need to get minus 8 because our equation has minus 8 as the middle term. So to get minus 8, what do we have to do here? This should be taken as minus 6 and this should be taken as minus 2. So let's put this here. 2x square minus 6x minus 2x plus 6 equals 0. This is what we do in splitting the middle term. See, now this 8x is split as minus 6x minus 2x. Take common factors out, 2 and x, and here you are left with x and here you are left with 3 because 2x times 3 becomes 6x, and invariably write x minus 3 here. It should be the same. This is for an easy understanding. How do we get x? By multiplying which number we get minus 2x? You have to get minus 2 is equal to 0. So we have x minus 3 times 2x minus 2 equals 0. So we have x minus 3 equals 0, x is equal to 3. 2x minus 2 equals 0, 2x is equal to 2, x is equal to 2 by 2, x is equal to 1. Now we have the zeros 3 and 1, right? 3 and 1. Now let us see how this can be related to our coefficients. Sum of its zeros. Now let us see what is sum of the zeros. Sum of the zeros here is 3 plus 1. Let us see if it has got anything to do with this. Now 3 plus 1 is, okay, I will just show like this, is 3 plus 1 which is 4. Right? Now this can also be expressed as minus of minus 8 by 2. Minus of minus 8 by 2. Here, what is this minus 8? Come back to this quadratic equation. What is this minus 8? Minus 8 is nothing but b. Minus 8 is b. Minus this, only this minus 8 is b. This minus we need to take minus b by, what is 2 for us here? A. Minus b by a. Now here, this minus b, here is minus, what is b in this? Coefficient of x. Coefficient of x. Divided by what is a, children? Coefficient of x square. Did you notice? We have to express them in words. Otherwise, here this b and b here are not the same. Here, this is constant because here this b, we are talking about linear polynomial, right? So this is constant. So here, this b is of a quadratic polynomial. So this b is coefficient of x. P is coefficient of x square. we can conclude sum of the zeros is equal to minus b by a, which is minus coefficient of x by coefficient of x square. Now let us see if there is any relationship with product of the zeros. These are the main two relationships that we take. So main two operations, product of the zeros. Let's see what the product of the zeros value will be. 3 times 1, 3. Now can we get these 3 by using combination of these coefficients? You see coefficients. Now can we take coefficients in the sense we can take constant also. Coefficients and the constant. So how do we get 3? 6 by 2. So let us say this is 6 by 2. And what is 6 in this, children? 6. Here is 6. So what is it now? It is constant. Constant by coefficient of x square. Coefficient of x square. So how do we write? Product of the zeros is equal to c by a, which is constant by coefficient of x square, right? Constant by coefficient of x square. Yes? So let's generalize this. Let's call the zeros of this quadratic polynomial as alpha, beta. Let's consider alpha and beta. Alpha, beta as the zeros of the polynomial. Which quadratic polynomial. So if we call alpha and beta, these are the Greek words that we use. So alpha and beta are the zeros of the polynomial. Then this can be expressed as alpha plus beta is equal to minus b by a. And here alpha times beta is equal to c by a. Right? So this is the relationship between the zeros and the coefficients. Let's try to understand this even better by taking another example. 3x square plus 5x minus 2 equals 0. So as we have seen earlier, let us take 3 times 2, which is 6. But we need to keep in mind we have minus 6 here as our product. So we need to find factors. Now 3 times 2 and 6 times 1. Now either addition or subtraction of the two factors, we need to get plus 5. Plus 5. And when you multiply them, you should get minus 6. Now let's see how we can use. Now this is 3 times 2. Yes, when we add, we get plus 5. But you please understand here, you get plus 5, 3 and 2. So for this to become plus 5, we need to have both this as plus. But when you multiply these two, you will not get minus 6. Right? So we cannot take this as our factors. Now let's see if we can do anything with this. 6 and 1 by subtraction gives us 5. Right? But we need minus 6. But we need plus 5 here. So let's take plus 6 minus 1, which gives us plus 5. But when you multiply this plus 6 and minus 1, we get minus 6. Right? So let's use this factor set. Plus 6x minus x minus 2 equals 0. So let's take common factors out. We're left with x plus 2. Then you have x plus 2 multiplying by what number? Multiplying by what number do we get minus 6? X should be multiplied by minus 1. Then we get minus 6. Right? X should be multiplied by minus 1. So 3x minus 1 x plus 2 equals 0. 3x minus 1 equals 0. 3x is equal to 1. X is equal to 1 by 3. X plus 2 equals 0. X is equal to minus 2. Now let this be our alpha and let this be our beta. Right? This is our alpha and this is beta. Now let's verify this relationship. Let's verify this relationship. Let's verify for this particular equation. Alpha plus beta is equal to minus coefficient of x by coefficient of x square. So what is alpha? 1 by 3. What is beta here? Minus 2. So minus, what is coefficient of x, children? 5. What is coefficient of x square? 3. If LHS becomes equal to RHS, then there is relationship. 3, this becomes 1 minus 6, which is equal to minus 5 by 3, minus 5 by 3 equals minus 5 by 3. LHS is equal to RHS. Verified, or you can also verify using this method. Now let's take the same relationship. Alpha plus beta is equal to 1 by 3 minus 2. So what do we get? We get 3. We get minus 5 by 3 minus, what is 5? Coefficient of x divided by what is 3? Coefficient of x square. Thus verified. Yes, you can use both these methods to verify the relationship. So now let us also verify product of the zeros, keeping these two zeros for this equation. Let us take relationship between product of the zeros. Let's verify the product of the zeros. Alpha times beta, which is constant by coefficient of x square. So what are the zeros that we have got, children? 1 by 3 times minus 2. What is our constant here? Minus 2. And what is the coefficient of x square? 3. So when you do simplification, you get, right? So which is LHS is equal to RHS. As I told you, we can also do it like that. What is alpha times beta? Alpha beta is equal to 1 by 3 minus 2, which is minus 2 by 3. What is minus 2 for us? Which is constant by coefficient of x square, right? Which is c by a. Both these ways we can verify. Similarly, let us see if we can get this relationship between zeros and the coefficients in cubic polynomial also. Now cubic polynomial standard form is ax cube plus bx square plus cx plus d. This is standard form of cubic polynomial. Now this is first, we just try to compare it with the quadratic polynomial so that it becomes easier for you to remember this because now we have already learnt about quadratic polynomial relationship. What is it, children? Alpha plus beta, that is sum of the zeros is equal to minus coefficient of x by coefficient of x square, right? Sum of the zeros, here if you notice, this is constant by coefficient of x square, right? Did you notice, children? In the denominator we have coefficient of the variable with highest exponent, which is x square. Now we have to apply the same thing here also. Now let us try to understand. Sum of the zeros is equal to, which is the highest in this? X cube is the highest. So coefficient of x cube, right? And what is sum of the zeros? Coefficient of x. That means in order, in descending order, if you go after x raised to 2, it is x raised to 1. So here it should be minus coefficient of, what is it after x raised to 3? X raised to 2. Right? Coefficient of x square. Right? And then product of the zeros is equal to, here it is, what is coefficient of x square again? Denominator doesn't change. Coefficient of x cube, and it is constant. Constant. Only thing is here we take minus for this also. But here we have one more relationship of the zeros between these two, which is sum of the product of the zeros taken two at a time. I will try to explain what this is. You don't have to get worried about these complicated terms. Product of the zeros taken two at a time, which means now let the zeros of this cubic polynomial be alpha, beta, and there's one more new symbol, gamma. Alpha, beta, gamma. Now let us take product of any two at a time and see what all combinations we get. Let's try to get this first, alpha, beta. Then we have, let's take the other two. We have beta, gamma, and then alpha, gamma, or gamma, alpha. So that it's easy for you to remember. Alpha, beta, beta, gamma, gamma, alpha. Any other combination left? No, we have covered all the three combinations. Right? Now, this is product of the zeros taken two at a time. Now, we are talking about sum of these three. Okay? We will write this later. This is, what is left now? We took x cube here in the denominator. We took x square and we have taken constant also. What are we left with now? Coefficient of x divided by coefficient of x cube, right? So if we put the symbols here, it becomes alpha plus beta plus gamma, sum of the zeros, and sum of the products of the zeros taken two at a time means alpha beta plus beta gamma plus gamma alpha, right? And the product means alpha, beta, gamma. Yes. So this is relationship between the zeros and the coefficients of cubic polynomial. This is cubic polynomial. All these are for quadratic polynomial. Like how we got standard form of quadratic polynomial in terms of zeros, similarly we can get standard form of cubic polynomial in terms of zeros. It's very important for you to understand that also. You don't have to go too much deep into it, but I'll just give you a standard form of cubic polynomial in terms of its zeros. So what's the first one? X cube. And what's the next one? X square. And what's the next? X. And this is constant is what? D. We'll talk about this later. Now, coefficient of x square. First, we took sum of the zeros. We didn't do anything with this. Sum of the zeros here, coefficient of x square. So in place of this, I take this alpha plus beta plus gamma minus alpha plus beta plus gamma x square, and then we have plus, what is this in between? Alpha beta plus beta gamma plus gamma alpha times x minus product of the zeros is alpha beta gamma. So this is cubic polynomial expressed in terms of its zeros, and this is in terms of its coefficients. You understand? If you notice, it's easy to remember. We have minus and minus, and then we have a plus in between. Right? Minus, minus, plus. Coefficient of x has got plus to do with it. Right? So this is the relationship between coefficients and zeros of polynomial. Now let's understand how we can use relationship between the coefficients and the zeros in solving problems. I'll just show example of just one or two problems. If your question is find a quadratic polynomial, the sum and the product of whose zeros are -3 and 2 respectively. This is one kind that you get. And another kind of problem for which we use the same equation. Find a quadratic polynomial whose zeros are 1/3 and -2. See, they appear to be the same, but they are not the same. Try to understand the question once again. Find the quadratic polynomial, the sum and the product of whose zeros are, means the sum of the zeros is -3 and the product of the zeros is 2. Here, find the quadratic polynomial whose zeros are 1/3 and -2. Right? Here zeros are given. Here sum and the product of the zeros are given. But for both, we use the relationship the standard form of quadratic polynomial in terms of its zeros. X square minus alpha plus beta x plus alpha beta. Yes, children, that's why I wrote in between. For both these, we use this, but we use differently. Right? Okay. Now here, for this, what we do? Actually, this is sum and the product. They have already given. This is alpha plus beta. And what is this? They have given product. Alpha beta. Right? So, write this form once again. Alpha plus beta x plus alpha beta. Now what we do? We put the values here. Minus. What is alpha plus beta? Minus 3x. What is alpha beta? 2. So our equation becomes x square plus 3x plus 2. This is a quadratic polynomial we found using the given information. Then what is this? Here we have to substitute the values of 1 by 3 and minus 2 in place of, see here, this is alpha, because what they have given is, these are the zeros. This is alpha and this is beta. So minus alpha plus beta x plus alpha beta. Right? X square minus, what is alpha, children? 1 by 2. What is beta? Minus 2x plus. What is alpha? 1 by 3. Minus 2. So it is x square minus, now take LCM as we did before. This is 1 minus 6x plus minus 2 by 3. Right? X square minus, this is minus 5 by 3 x minus 2 by 3. Right? To get it in the standard form, let's multiply this entire equation by 3. That means we are multiplying every term of this equation by 3. And then see what happens. 3x square minus plus, we are multiplying every term by 3, remember. Yes, we multiply every term by 3. See here, right? Now these 3 get cancelled. So what are we left with? 3x square plus 5x minus 2. This is our quadratic polynomial which we found using the zeros. This is how we use this relationship, and you can apply the same approach to form a cubic polynomial. There again you will be given relationships like this. Sum of the zeros and sum of the products of the zeros two taken at a time, and then product of the zeros. There will be 3 relationships in terms of cubic polynomial. Here they may give all the 3 zeros and you have to use a similar relationship and form a cubic polynomial. In this session, let's try to understand more about the zeros, especially of cubic polynomials and division algorithm for polynomials. Let's understand the zeros and then division algorithm for polynomials. Division algorithm for polynomials. If we know that cubic polynomial has at most 3 zeros. Cubic polynomial has at most 3 zeros. If we are given cube minus 3x square minus x plus 3. Now we are given this cubic polynomial whose one of the zeros is, whose one of the zeros is 1. Whose one of the zeros is 1. We understand how we can find. That means how many more zeros we have to find? We know it has at most 3 zeros. We have been given 1 zero. Means we have to find 2 more zeros of this cubic polynomial. Yes, we'll try to understand this. When I say 0 means x is equal to 1, right? Which this can be written as x minus 1 is equal to 0, right? Okay, we'll keep this on one side. Now let us take this term 15, this number 15. Now what are the factors? 5 and 3 are the factors, right? 5 and 3 are the factors. When I say factor, that means it can be 15 can be divided by this. When 15 is divided by this, the remainder becomes 0. And if 15 is divided by 3 also, the remainder becomes 0 in a long division method, right? Similarly, when I say x minus 1, similarly, when you divide this cubic polynomial by x minus 1, the remainder will become 0. So we can use this as a factor for this given polynomial and try to find the zeros, and this is the method we use. I will show you how to find zeros of this, remaining zeros of this cubic polynomial. I will rewrite this: x cube minus 3x square minus x plus 3 divided by x minus 1. I am taking this as a factor to divide. I always suggest you take your quotient here, not here. Okay? Because it becomes difficult for you to write the terms. Now, the procedure is, you need to find the first term of your quotient. So, in your working column, write first term, compulsory. X cube divided first term of your, what is this? Cubic polynomial should be divided by the first term. So, this variable of your divisor. This is x, which is equal to x raised to 3 minus 1, x raised to 2. So, the first term of your quotient is x raised to 2. So, multiply this, x square times x will become x cube plus into minus x square, right? Sign change, cancel, minus 3 plus 1 minus 2x square, bring this down, this term to be brought down. Now we need second term. We will take minus 2x square and divide it again by x. So, this becomes minus 2x. I am using laws of exponents here, minus 2x. So, we have to take the entire quotient here, minus 2x. So, now let's multiply minus into plus minus 2x times x, 2x square minus into minus plus 2x, right? Sign change. So this will be minus x minus 2x becomes minus 3x. Now bring the last term down. Again, what do we do, children? Minus 3x divided by x. You are left with minus 3. You have to write it right here. Third term of your quotient, right? So this will be minus into plus minus 3x minus into minus plus 3, sign change, gets cancelled, 0. Now we got this as quotient. Now the quotient is x square minus 2x minus 3, right? So it becomes x square minus 3x plus x minus 3 equals 0. Take x common, x minus 3. So here it is x minus 3. When you multiply this x by 1, you will get this x. So it should be plus 1 here. So we have x plus 1, x minus 3 equals 0. You get x is equal to minus 1, x is equal to 3. So what did you get, children? We already had 1 0 which was 1. The other two zeros are minus 1 and 3. So we got 3 zeros of this to be polynomial now, because we can get at most 3 zeros. 1 is given, 2 we found. Using this, understand division algorithm for polynomials. When we are talking about division of numbers, let's take for example dividing 15 by 2. Let's apply this. 15 divided by 2. Right? Now this entire relationship can be expressed like this. How do we get this 15 using all these numbers now? 15 is equal to 2 times 7 plus 1, right? 2 times 7 plus 1. So what is this now? This is our dividend. And what is this 2? This is our divisor. And what is this 7? This is quotient. And what is this? Remainder. Remainder. Right? Dividend is equal to divisor times quotient plus remainder. When this relationship is applied for a polynomial, when this relationship is applied for polynomial, it becomes division algorithm for polynomial. Let's try to understand this better with an example. Divide 2x square plus 3x plus 1 by x plus 2. Now this is like our 15 in the example and this is like our 2 in the example. So let's divide 2x square plus 3x plus 1 by x plus 2. What method did we follow? First we'll take first term, which is 2x square, and divide this by x. It becomes 2x, 2, this is 1 minus 1, 2x. So the first term is 2x. So this becomes 2x square plus 4x. Change the sign. Minus 4 plus 3, minus 6. Bring this one down. Now the second term is minus x divided by x. You get minus 1. Minus 1 is your second term of the quotient. This is minus x minus 2. Cancel. 3. Now let's verify using division algorithm for polynomial. If we call this as our p of x, this is g of x, and this as q of x, and this as r of x. This is p of x, this is g of x, this is q of x, and this is r of x. Now let's apply this division algorithm for polynomial using this. What did we see in the earlier discussion? Dividend is equal to divisor times quotient plus, what did we get? Remainder. Right? So, dividend, what do we call in polynomial? P of x. What is divisor in polynomial now? G of x. What is quotient? Q of x. And what is our remainder in polynomial called? R of x. Right? Now what is our P of x? We will write this 2x square plus 3x plus 1. What is G of x, children? X plus 2 times, what is q of x? 2x minus 1. What is r of x? 3. If our LHS becomes equal to RHS, then we have verified it. So this is 2x square minus x plus 4x minus 2 plus 3. We'll go on writing this. LHS in every step. 2x square plus 4x minus 3x plus 3x plus 3 minus 2 plus 1. Thus, we verified using division algorithm for polynomial. This is division algorithm for polynomial. Here we have been given two polynomials, t raised to 4 minus 3 and 2 times t raised to 4 plus 3 t cube minus 2t square minus 90 minus 12. This is another polynomial. Now, to check whether the first polynomial is a factor of the second polynomial, we have to do division of this p of x using the first polynomial as g of x. We have to divide P of x by G of x. This is our P of x and this is our G of x. When you divide, if the remainder is 0, then yes, it is a factor. If remainder is not equal to 0, then no, it is not a factor. It is not a factor. Clear, children? If you are given two polynomials, you are asked to check whether the first polynomial is a factor of second polynomial. Do the division, and if your remainder is 0, then you should conclude yes, the first polynomial is a factor of the second polynomial. If the remainder is not equal to 0, then this is not a factor of this given P of x. Next, we will try to understand how do we have to find whether the given polynomial is a factor of another polynomial. For example, to find whether this first polynomial is a factor of this second polynomial, it's very easy to find. So write this as your P of x. This is your P of x, and t raised to 4 minus 3 is your G of x. When you divide this G of x by this, when you divide this P of x by this G of x, your remainder should be 0. If you get remainder 0, then yes, it is a factor. If remainder is not equal to 0, then the given polynomial, the first polynomial, is not a factor of the second polynomial. No, it is not a factor. Yes, so we do the division in the same method that we discussed earlier. Here, with this, we come to the end of discussion on polynomial. If you have any doubts, you can always ask in the comment section, or you can always WhatsApp me. And Nittur Central School students can collect the activity sheets, the worksheets, and the related question papers from your respective class WhatsApp groups.